Chapter 5, Congruent Triangles. 5a is angles of triangles. So we're going to start by classifying triangles by sides. So this first triangle has 3 congruent sides. All the sides are congruent, and we call this an equilateral triangle. So lateral means sides, so equal sides, okay? On the next one, we have 2 congruent sides and then a non-congruent sides. This is called an isosceles triangle. Okay, and last but not least, we've got this one with 3 non-congruent sides. This is called a scalene triangle. Okay, so that's how to classify a triangle by its sides. There's only 3 ways. We can also classify a triangle by its angles. So I'm not going to get out a protractor, but just based on looks, this first triangle here on the left looks like all 3 angles are acute. It looks like all of the angles are less than 90 degrees. So that means we could call this an acute triangle. Okay, so it would have to have 3 acute angles to qualify. Okay, if a triangle has just one obtuse angle, like this angle at the top appears to be obtuse, so let's just say that's 100 degrees. Okay, so now it's definitely an obtuse angle, and this would then be an obtuse triangle. Okay, a triangle can actually only have one obtuse angle, so just one obtuse angle qualifies it as an obtuse triangle. Okay, if there's a right angle, let's say we've got a right angle right there, then we've got a right triangle. And a triangle can only have one right angle. So that's all you need to qualify, okay? If all 3 angles are congruent to each other, let's say these are all congruent, then this is going to be an equiangular triangle. Okay? So you could also say that it's an acute triangle because the only way, those 3 angles all have to be 60 degrees. That's the only way it's going to work out, and we'll talk about that more later. But it's also going to be equilateral. That always works out that way too, and we'll talk about that later. But just showing that, yeah, every equiangular triangle is also an acute triangle and an equilateral triangle. So there are different ways that you can classify these. Any triangle you can classify by sides and angles, and then equiangular ones you could classify as equiangular and acute. So 2 different ways to classify that just by angles as well. Okay. All right. So this example, we're going to classify this triangle by its sides. So what we want to do is find the length of all 3 sides. You could eyeball it, and so by the sides we're looking equilateral, isosceles, or scalene. So you could make a guess. It sure doesn't look equilateral to me, but I want to find the actual lengths of the sides just to make sure. So what I'm going to do is use the distance formula here. So distance formula here, I'll write it up here. That's the one where we're got the big square root. We're subtracting the x's and squaring. And then we're subtracting the y's and squaring. And we add those results, take the square root of the whole thing. Okay, so let me start with AB, with the top of this triangle. Let's find the length of that. Okay, so for my x's, I'll do 7 minus 0 and square. And then for my y's, I'll do 1 minus 3 and square that. Okay, so I've got 7 squared plus negative 2 squared. And then I've got 49 plus 4, so I've got root 53. Okay, now I could put that into a calculator and get a decimal approximation, but I'm just comparing these sides to each other, so I'm not going to bother with that. I just want to see if the other sides come out to root 53 or something else, really. I just need to see if I have congruent sides or not. Okay, so that was for that side. Here, I'll use red for this, so that for this next side, I'll do the left side, which is AC. Okay, I'll subtract the x's, 1 minus 0 for the x's, and square. And then for the y's, I'll do negative 1 minus 3 and square that. So let's see, I have 1 squared plus negative 4 squared. And I got root 17 for this side. Okay, so those two sides are not congruent. I'll do the last side in green. Let's see, I'll use this space off to the right here. The bottom of the triangle would be side BC. See if I can squeeze this in here. Okay, so for my x's, 7 minus 1 and square. For my y's, I'll do 1 minus negative 1. Okay, I'm going to be able to fit it here. All right, so 6 squared plus 2 squared. I got the double negative there, right? So that's going to be 36 plus 4. That comes out to the square root of 40. Okay, now looking at those side lengths, all three of them came out to something different. So I can say definitively for sure that this is a scalene triangle if I'm classifying it by its side lengths. Okay. All right. So we don't have a good way yet to find the measures of the angles. We'd need trigonometry for that, which we'll get into in a future chapter, but we can check for right angles. Okay, so if I want to know if this is a right triangle, I'm not going to test all three angles. I'm just going to, because it's pretty clear, angle A is not a right angle, angle B is not either. Angle C looks like it could be a right angle. So I am going to test that one, okay? So what I want to do is find the slope of this line and then the slope of this line as well. Because if they're perpendicular slopes, then that means I've got a right angle there, which means I have a right triangle, okay? So I'm going to test the slope of those two sides. Here, so my slope formula is going to look like this. It's the difference of the y's over the difference of the x's, okay? So for the left side, for AC, let's find the slope there. I'm going to have, for my y's, I'll do 3 minus negative 1. And for my x's, I'll do 0 minus 1. Okay, so 3 minus negative 1, that's the same as 3 plus 1, it's 4. And on the bottom, I have negative 1. So my slope there came out to negative 4. Okay, and then I'll test the slope on the, for the bottom, which is BC, side BC. Okay, so my slope here, let's see, 1 minus negative 1 for the y's, and 7 minus 1 for the x's. And so that's going to come out to 2 over 6, which reduces to 1/3. So even though these appear, those two, it kind of looks like it's a right angle, we actually don't have a right angle here because this slope here is 1/3, and this slope is negative 4. So those are not going to be perpendicular lines because they would have to have opposite reciprocal slopes. So if we had something like negative 4 and 1/4, for example, those would be opposite reciprocals and I would have a right angle. But since I don't have that happening here, my answer is no. So I do have a way to check for right angles, but that's the only way we can check at this time. All right, let's look at the triangle angle sum theorem. This says for any triangle, the measures of the three angles are going to add up to 180 degrees. That's always true. So then that means anytime we have a triangle where we know two of the three angles, like we do in this next example, then we can find the third one. I can say here that x plus 100 degrees plus 32 degrees is going to equal 180 degrees. Okay, I can solve for x here. So I'll combine the 100 and the 132. Okay, and then I'll subtract 132 from both sides. And then x will come out to 48 here. Okay, I don't need the degree symbol actually in my answer because there's a degree in the picture. I'm saying what number I'm putting in there in front of the degree symbol. Okay, all right. So that's for interior angles, when we're talking about the three angles add up to 180. But we also have a triangle exterior sum theorem. So before I show you, we got to talk about what an exterior angle is. This angle right here would be an exterior angle. So if you extend one of the sides of the triangle, then it'll form an angle on the outside. That's called an exterior angle, okay? So these are all exterior angles, okay? So let's find the measures of these angles here. I can find them because I've got linear pairs. Those two angles are going to add up to 180, so that means that this must be 120 degrees, okay? This must be 120 degrees as well. Same thing down here, because we've got linear pairs in all three spots. Okay, so if I'm finding the sum of the three exterior angles here, I just add up 120 plus 120 plus 120, or multiply by 3, and then that's going to come out to exactly 360 degrees. Okay, so on the next example, this one's not an equiangular triangle, but we can still use the linear pairs, right? I've got a linear pair here. This must be 80 to get to 180, okay? And if you do 180 minus 34 down here at the bottom, that'll give me 146. And if we do 180 minus 46, that would give me 134 degrees, okay? So let's add up these three angles and see what we get. And when you add these all up, we get 360 degrees again. Wow, same answer. Well, that's because the sum of exterior angles for any triangle is always 360 degrees. So up at the very top, I can put that in there. That's always the case. So you don't actually have to do the math on these problems once you know that. You just know the answer is going to be 360. Okay, but I was just showing where that 360 is coming from. I want you to understand that we're adding up those exterior angles, okay? All right, now let's talk about something called the remote interior angles sum theorem, okay? So we've got an exterior angle here. Angle C would be an exterior angle. And we've got three interior angles. But when I'm talking about remote interior angles, remote means far away, right? You use the remote control to control your TV from a distance. So this angle and this angle, we can consider those remote interior angles. And what I mean by that is that those angles are the ones inside the triangle that are farther away from that exterior angle. Okay, this one where I'm putting a little dot, that would not be remote because it's right next to the exterior angle. But the other two are farther away, okay? So here's what the remote interior angle sum theorem says. It says that if you take the sum of the two remote interior angles, so in this case that would be angle A and angle B. So if I add up the measure of those two angles, it's going to be equal to the measure of the exterior angle, okay? So, yeah, these would be my remote interiors here, and then this would be the exterior angle, okay? So using that idea, on this next example, you could find the missing angle in the triangle and then use that to solve for x. That's fine. But you can also just take these two and add them up, and that should equal x. So x is going to be 100 plus 50. And that means x is 150, okay? And there are times when you need the remote interior angles theorem. Even though we could get around it here by finding the missing side of the triangle, this next problem, that's not going to work. We can't find the third angle in that triangle because we only have one of the three angles. But what we can do here is say, oh, these are remote interiors. So if I add those together, it should equal 2x plus 4. So I can say x plus 70 is equal to 2x plus 4, and I can solve that then for x. So I'm going to get those x terms together. You could either subtract 1x or 2x from both sides. I'm going to subtract 1x because I'd rather have the x be positive. Okay, and then, whoops. And then I'll subtract 4. And I'm going to get 66. And there's x. Okay. All right, that is the end of the section, and I'll see you next time.